Here's a question where we're asked to use Hess's law in order to find the delta H for an overall reaction. They give us several steps in a reaction mechanism and the delta H associated with each of those steps, but we need to use this as like a puzzle to come up with the overall equation chemically and add up the delta H's of each step after flipping and multiplying to make the overall equation. This is quite a challenge in bookkeeping. We've got to really keep track of what needs to go where in order to produce the overall equation. So some basic things at first. In the overall equation, we have the substance C6H4 and then OH2. Its coefficient is 1 in the overall equation. The only place that substance appears in the reaction mechanism is in the first step, and the coefficient is what matches what we see in the overall equation, and it's on the correct side. Based on that, I'd say whatever we do to the other steps, let's keep this first step untouched without changing the value of delta H and without flipping it around. Let's also notice that the only place that H2O2 appears in the mechanism is in step 2 of the in the second reaction of the proposed mechanism, and it's on the incorrect side. It's on the right side in step 2's reaction, and it's on the left side in the overall equation, but the coefficients do match. So let's take the second reaction and flip it around. And then lastly, I would say I noticed that liquid water appears in the overall equation on the right side and with a coefficient of 2. The only place liquid water appears in any of the reactions below is in the last reaction, reaction 4. It's on the correct side, to the right side of the arrow, but its coefficient is not correct. It's got to have a coefficient of 2, and right now as it's written, its coefficient is 1. So let's take that last reaction and double coefficients, which will in effect double the value of delta H. Because we took that last equation and flipped it around, and also because gaseous water does not appear in the overall equation, but it does appear in step 3, and upon doubling the step 4, we've got to get gaseous water to cross out. Well, the way to do that is to take step 3 and double it. Let's rewrite each of these equations after having flipped or multiplied or just kept as is. And accordingly, we'll change the value of delta H if it should change. So step 1, we kept exactly as it was originally written. And we keep the value of delta H as a positive 177.4. Step 2 in the mechanism, we flip around. And accordingly, the value of delta H gets an opposite sign. Right now it's negative, it becomes positive 191.2. Step 3 of the mechanism, we said we should double it. So let's take all of the coefficients and double them. And I'm going to note the state of matter for water because there's a difference. And we'll double the value of delta H. So instead of a negative 241.8, we'll write down negative 482.6. And then with the last step, we also doubled it. So I'm going to write 2 molecules of gaseous water becoming 2 molecules of liquid water. And this value of delta H is twice as much. Still negative though, because we didn't flip it around, we just doubled it to a negative 87.6. Now let's look for things to cross out. If we were to add all steps in this mechanism, we could say gaseous water crosses out. 2 molecules of gaseous water on the left side crosses out with 2 molecules of gaseous water on the right side. The oxygen molecule crosses out. The hydrogen molecule crosses out. But notice that, actually there's 2 of them, 2 hydrogen molecules on the right side, and a single place where hydrogen is found, but there's a coefficient 2 on the left side. So those all cross out. What do we have left? Well, let's write that down. We've reproduced the original overall equation. What we've produced by summing up all of the reactions in the mechanism, after flipping and multiplying if necessary, is the overall equation. Now to get the final answer, simply add the manipulated delta H values. So on my calculator I'm going to punch 177.4 plus a positive 191.2 minus, note there's a negative sign, minus 482.6 and minus 87.2. The overall delta H then is negative 398.4 kilojoules, or you could state that as kilojoules per mole if you wanted.